Welcome, everybody. I'm Jaime Rodriguez. I'm a Windows 8 technical evangelist. And I want to welcome everybody in the room. And I want to remind you that we're doing live today. So I want to welcome everybody that's online. So please keep that in mind as you go through the day for today. This is our agenda for today. And I'm really, really excited to show you guys this. Because what we have is a whole day of just C++ uninterrupted. I used to be a C++ guy like 10 years ago, and I did .NET, I did JavaScript, I've done Objective-C, every other language, and I can honestly tell you I've been doing more C++ in the last 4 months building Metro-style apps than I did in the last 10 years. Before that, I was C++ full-time, of course. So what we have here is the agenda, and it's fully packed. And for those of you in the room, you're probably wondering, when am I going to get a break? So let me walk you through what we're doing. Because we're online, we want to have content throughout the day. We're going to go uninterrupted. But for those of you in the room, every time you see video, those are the times where you can get up, stretch, go to the bathroom, get your smoke break, whatever you want to do. Right? All of the videos will be posted online, so you're not going to miss out on anything. Don't be afraid to get up if you get tired, because we have a lot of content. We've packed a lot of stuff. Everything that you're going to need, everything that I've learned from the last 4 or 5 months working with really big companies like Citrix, Barnes & Noble, SQLite, Evernote, it's all here. So that's what we have for the whole day. And unfortunately, because we did this and we wanted to optimize the day for C++, I do have to warn you that we missed out on a few things about Windows 8. So for those of you that have been hearing about Windows 8 and want to hear about the developer story and the value prop behind the Windows Store or push notifications, we don't have a lot of those. We have a lot of C++. The push notifications, the contracts, all that stuff is much, much easier. So I want to recommend you that you go check our the Windows Developer Center, dev.windows.com, or you go in there and sign up for a different camp. We have Windows camps around the world, just like this one. We have plenty of Windows camps around the world, and there we get very heavy into all the Windows 8 features. You're still going to see the features today, so don't worry, but I do want to do it justice and tell you that, hey, there's a lot more. You should follow up at the Dev Center or at the camps. Last thing I want to tell you is, again, we are live. A lot of the Q&A, we want you to, if you're in Twitter, go ahead and follow the tag, this #CH9 Live. Put your questions there. Start a conversation so that the people online can hear what's going on here, and so that you can actually contribute to the Q&A for the panels and everything else. That's it. We hope to have you have some fun today. Again, make sure you get up during the breaks. Don't worry about missing out on the video. Let's get to Herb, because I know everybody wants to see that. HerbSutter.
Well, welcome everybody. Thanks for getting up early today. We have a full day for you, and we are excited to be able to talk about how to create stunningly beautiful modern Metro-style tablet applications in C++ and have them be high-performance, battery-sipping, stunningly beautiful applications too. So we're going to show you quite a bit running on laptops and tablets here today, and then throughout the day do deep dives into more information. But in this talk and in the day, we're going to focus on the questions that I know that you're thinking about. How do I do this using the Visual C++ compiler? How hard is it really, Microsoft? And how much of my code can I bring with me and not change and stay in nice, portable, standards-conforming code? And then finally, okay, say I do buy into this Metro thing in addition to the desktop applications, which we still fully support. How much of Visual C++ and all its power, including the new things we're adding in this release, are available in a Metro application? So we'll cover all of those things today and give you a flavor over the next few minutes. But first, a few updates. Some may wonder, is this Metro thing ever going to go anywhere? Are there people who are interested in modern tablet applications? Well, I think there's a lot of data to show that that's true. But if you've been following since the Windows Consumer Preview was launched, in just the first 24 hours, there were over 1 million activations of Windows 8 Consumer Preview. This is not partial downloads. This is not downloads. This is installed users activating and using the system in just the first 24 hours. And then you might say, well, okay, but how many of those will buy my application in the App Store? Well, when the beta came out, so did a beta App Store, and Since the short time that Consumer Preview has been available, there have been millions and millions of app downloads, not just in one geography, but around the world in over 200 geographies. And that's where our customers are. That's where we can reach and deliver these stunning, modern applications on a beautiful, fluid platform. So that's where we're going and the why. Now let's talk about the how. So there are four main things I want to cover in my part here, and I'm going to a few times invite people up to demonstrate parts of it so you can actually see how it works. Then we'll go into deep code and deep dives the rest of the day. The first thing I want to do is talk about an overview of what is this Metro style thing anyway. What is WinRT at a very high level, and especially what's new in Visual C++ 11 that lets me talk to WinRT, the new Windows runtime environment, and build Metro style applications. So that's the first part. Then we're going to talk about why would you use C++ and how do C++'s strengths fit a Metro-style application. Because you can build Metro-style applications in JavaScript, C#, or in Visual C++. So the main guidance we give is use the language you're familiar with. If you already have a lot of knowledge of C++ or of C#, that's the thing you would probably start to think of by default. But there are some differentiators, some things that C++ can do, and so we'll focus on those, including, in this case, portable code that runs on many platforms and many compilers. Then we'll talk about the user interface, and this is the thing that you most see when you think Metro, because that's what's right up front. And like other languages that Microsoft supports, you can use HTML5 and JavaScript as your UI, you can use XAML. With C++, you can also use DirectX. And you can use these in combination, and we'll show you how. Finally, C++ is well known for being able to deal with demanding applications. High-performance code can often require lots of number crunching. And so when you talk about that today, heavy number crunching means parallelism. And that's because our tablets and even our smartphones are no longer toys. They are pocket and purse-sized supercomputers. And we had better program them that way if we really want to get the most out of them. We had better be able to use the multiple cores that are already on today's commercially available off-the-shelf tablet hardware, to use the GPUs that are already there for compute when it's appropriate for our application. And not only will that give us better performance, it means we'll sip battery because we're using the right hardware that's matched to the job that we're trying to do. And that's how you get high performance and long life together, which is what we all want to get. Now, in particular, we've already had the parallel patterns library. We are now adding in this release support for the C++ 11 standard async and futures model, and automatic parallelization and vectorization, and C++ AMP. So we'll focus on what's new, but there's a lot there already, and we'll talk about each of those. So let's begin with an overview of Win8, WinRT, and how does C++ and C++ applications fit into this world. So you've probably seen this slide or many like it. They talk about the whole WinRT model. And notice on the right-hand side, desktop apps are still there. Today we're focusing on Metro apps, but please, please, do not interpret today as saying, Microsoft is saying, and Visual C++ is saying, that Metro apps are the future, you should never bother with that other stuff again. That is so not the point. The point is you can do it all, and we are supporting desktop apps better than ever in this release. But Metro is so new that people have to be ramped up and on board to figure out, well, how do I do this also now? And that's why we're spending today talking about this. So when you look at how this all fits together, notice that C and C++ are central to both the native and the desktop and the Metro style models. When all the things that have been going on in the industry with GPU, with Windows 8 and tablet applications, with ARM targeting, all happened, it made for a very busy 2 years for us because the Microsoft world is built on Visual C++. That means we had to enable all of those things. And so we'll focus on how C and C++ allow you to use this centrally in both parts of this world and how they fit well into this modern Metro ecosystem. So the desktop apps are still there. We're going to focus on the left-hand side of the screen. How do you get two components, two languages to talk to each other? And this is something C++ developers, even if you never touch JavaScript or touch C#, and the code you write never touches C# or JavaScript, you care about. Because if you ship 2 DLLs today, what boundary do you use? Use a C level boundary, ints and pointers. Why? Because even if both modules are built in C++, unless they are compiled with the same compiler, the same version, and compatible switch settings, what's going to happen? Object layouts are going to be different. The binary interface is not standard. So even if you are doing pure C++ to C++, you care about having ABI safe types. But especially in this world, if you are talking to other languages, to C# and JavaScript, that is where Windows has invested in this Windows runtime object or component that has a surface area that has the richness of objects and classes, of exceptions instead of H results, and that all languages can talk to. Now you get the portability. Therefore, you're going to pay something for that. Use it in the right place when you're going to be able to interface with that code. But now, once you have this component that is built using C++, C#, or Visual Basic, the way that the rest of the world gets to know about it is through metadata. So the Windows metadata, the WinMD information, describes the classes, the functions, all of the exceptions and the things that can happen, the properties, the delegates, the events. And then each of the language compilers, whether it's the CLR, the C++ compiler, and the JavaScript engine, each have a projection layer where they map that to what their users, what the programmers using writing their code understand. And so our job has been to write that first gray box, the projection for C++ on my team. And so that's what we're going to focus on. Now, there are 2 projections that we've got. The primary one, which we encourage people to use, is the one on the left, C++ CX, C++ component extensions. And if you've ever done C++ CLI, this will look very familiar because it's virtually identical syntax, which is interesting because we didn't set out with that as a design goal. It turns out that we did a reasonable job 5, 6, 7 years ago, we think, in how to expose a foreign object-based type system to C++. So C++ CX are language extensions. They're well aligned with C++ CLI. And if you are only using Windows components, then you are likely to only ever see the hat declarator instead of a pointer. It's basically a compiler built-in reference count and smart pointer. But because it's built in, we can optimize it. And ref new instead of new for allocation. There are other extensions, but if you're just consuming other components that are in Windows or that are already authored, that are WinRT, that's all you'll see. And by the way, if you use auto and lambdas, you'll see them even far less. But we also have full authoring support, so you can create all of these rich WinRT types from within a Visual C++ source file. Now, we also support a library-based approach. This is intended mainly for consumption. And there you have a computer type, that's a smart pointer type, and a make template instead of ref new. So that part should be pretty familiar. Authoring requires a bit more because you've got to do lots of middle and attributes. It's possible, but you have to do a lot more. So the language extensions have made that very seamless for you. If you want to author components, we encourage you to do that on the left-hand side in C++ CX. So as a one-slide cheat sheet summary of what's in C++ CX, you have the ability to declare interfaces, classes, and value types using ref class, value class, interface class, just as in C++ CLI. You can also have properties, methods, and events. The properties, events, and delegates, they go together, where an event is sort of like a property of the type delegate, except you add and raise and remove instead of get and set. And there's even support for native generic interfaces, which is kind of interesting when you remember, well, wait a minute, C++ has always done templates, but this is over an ABI boundary. That's genuinely interesting. But that's one set of extensions for dealing with the WinRT object model and exception model. So all of those go in that first bucket. Here's a set of bindings to express these new kinds of types, which are different from native C++ types because they're opaque. They hide their implementations. Once you're done with that, there's only 2 things you need, and they're both the only things you need for consumption. And that's to deal with allocation, ref new, and to deal with pointers and references. And there you'll almost always use hat as a strong pointer, a smart reference counted pointer that guarantees that object will be alive. And if all you're doing is consuming, you only see those last 2. But the full richness is there when you want to author things, because that's what we do. We author components for others to use as well. Here's an example in one slide of what this code looks like. And you'll notice that much of it looks like plain old C++ code. Now you'll notice in the first line that the parameter type is a hat, and the second line as well. But other than that, this is very familiar. And in fact, those were the only things in this slide that actually needed to use any extensions. Now, just to make it explicit, I'm also showing, notice near the bottom, ref new, about a few lines from the bottom, to explicitly allocate a new delegate type. You could have used a lambda, and if you'd done that, you wouldn't even see that, because we can bind standard C++11 lambdas to these delegates. So you can write standard portable code that binds well and elegantly to these delegate types, because all it is a type-safe function pointer. We know how to do that in C++. And so that's a natural binding, just as C# mapped their natural language syntax to those WinRT types. And then a couple of lines up from that in the very middle, notice we declare the rotation variable. Even that hat you wouldn't need, because what would you write? Auto, right. Let's get used to that, because auto is our friend. So if we'd used the lambda and auto, the only hats on this screen we would have seen were in the first two lines on the declarations. So that's a very nice, non-invasive place to be. And you'll see more of C++CX, but this gives you a flavor for what's there and how it works. So now let's move on beyond the overview to talk about C++'s strengths. Now, if you're already familiar with C++, just like if you're already familiar with C#, use the language by default that you're already familiar with. You're trained in it. Use it. If you're interested in high performance, C++ is really good at that. If you're interested in efficient use of hardware resources, C++ is really good at that. And if you're interested in code that runs on multiple operating system platforms, including multiple operating system platforms for mobile devices, C++ is pretty much your only solution in the industry today. So let's talk about those strengths of C++. Again, let me just repeat to emphasize, the point of all of this is not, look, shiny new object, everything must be Metro and WinRT, leave that native stuff behind. No, you should be writing 99% or more of your application, of the internals of each module, in your language of choice, in C++, in our case. Portable, standard, conforming C++. On the boundary, we already map to other kinds of type systems. Today, if you want to expose code to non-C++ applications and modules, what do you need to do? You write a flat C API. Now you can write a non-flat, object-oriented API on Windows that will let you talk about objects and exceptions in a rich and very powerful way with strong abstractions across an API boundary to other languages safely. So this is intended for use on the boundary. The internals of your module should still be portable, standard C++, and that's what we encourage. Now, it's easy for me to get up here and say, well, just port your code. Trust me, it's easy. You might even believe me, in which case I have a bridge. But it's worthwhile seeing what people have already done, and keep in mind that we're talking about a beta operating system and a beta app store, and what people have already accomplished with the tool set and the platform that's been made available. Evernote is a nice application if you've been using it in the App Store, because it's already in the App Store if you're using the consumer preview. You'll notice how wonderful, fluid, and responsive it is, and it's only going to get better as time goes on. Peter Kvitek of Evernote pointed out that his experience was that porting their code to the Metro SDK was easy, and they're now sharing most of the business logic and persistence layers with non-Metro code. That's exactly the right way to go, and shows the power of being able to take our existing assets and use them now also in a Metro-style application. Now, it would be nice if we could get an experience report. Wouldn't it be nice if we could actually talk to somebody who's well known in the industry, who's got a major application that's used on more than a few thousand machines, and ask him, well, how hard was it really to port that to Metro? So I'd like to now introduce SQLite. And in particular, we have with us today a primary author of the SQLite, one of the most widely used embedded database systems in the world. Please join me in welcoming Dr. Richard Hipp.
Welcome, Richard. Thanks. Thanks, everybody. I'm Richard Hipp. I am the creator of SQLite.
and I'm here today to tell you that SQLite works great on Windows 8 and the Metro SDK. Quick show of hands. Who here knows what SQLite is? Okay, great. For the 4 or 5 of you who didn't raise your hand, SQLite is a small, embeddable, self-contained SQL database engine. You compile it into your application, use it for storage. It's fully ACID, it's compliant, it's very small footprint. It's used in thousands and thousands of applications. We've got over 2 billion deployments over worldwide. That's 2 and 9 zeros. And it runs on every operating system, all the major operating systems, including every version of Windows, all the way back through Windows 95. So people have been coming to us and saying, hey, are we going to be able to use SQLite to build our Metro-style apps? And so a couple months ago, we downloaded the consumer preview to give it a try. And of course, if you're building the classic desktop apps, no changes are necessary. The existing SQLite code works great just out of the box for your desktop applications on Windows 8. But if you're doing Metro apps, of course, we had to port it a little bit because some of the APIs are a little bit different. There's not that much change. It took us a couple of days aggregate work to make the changes we had to do. And after that, everything's working great. Over here at the keyboard, I've got Joe Mistashkin. He's the Windows guru for SQLite. And he's showing us, he's brought up some diffs online for our changes. Now, we checked all of our changes in, and they're on the SQLite website. You can go there, and if you click around a little bit, you can find this page where all the diffs are shown. It's not right up on the, you'd have to click a little bit. All the search engine spiders find it every day, but you be persistent, you can find it. And this, on the left-hand side of your screen, is the current release of SQLite, and on the right is the code that's in this branch that we've done that contains the port that runs on the Metro SDK. And you can see, for example, at the top of the screen, we were using this interface initialize critical section, which runs on all versions of Windows all the way back through Windows 95. But for the Metro style apps, that's not available anymore. So we had to change it to use initialize critical section EX. And now our code base is unified. It's a single file. It works on all operating systems. So we couldn't just make the change because this still has to compile on legacy builds for Windows 95. And I guess initialize critical section EX only became available in Vista or somewhere along in there. So we've got some sharp defined magic that happens, but when you're compiling for your Metro apps, all you have to do is set that one macro in your header, and the right thing happens.
Now, Richard, you mentioned that it had taken you a day or two to port your application over. So in that day or two, can you give us a sense of what percentage of lines of code did you touch? Because this is great if you had 100 lines of code, but something tells me you have more than 100 lines of code. Yeah, the total code base that's delivered is a little bit over 130,000 lines of code. And the differences between our trunk and this branch that contains our port is about 1,000 lines of code. So it's less than 1%. Less than 1/10 of 1%?
No, less than 1%.
Yes.
So, but really, whenever we do something like this, we also do a lot of refactoring and cleanup and stuff. And so if we'd been trying to minimize the changes, we could have kept it down to about 100 lines of code. It really was very simple to do. And these examples show you typically the kinds of things we had to do. So initialize critical section. What else can you show us here, Joe? There you go. The get tick count. Apparently, so now the WinRT interface only supports get tick count 64, whereas that only became available in Vista, if I recall. So we still have to have this ifdef here, and we had to start using it. If we had originally coded to Vista to begin with, this change would have been a no-op. But because we originally wrote SQLite back in the days of Windows 95, we kind of had to bring it up into the 21st century. So this gives you an idea. It's very simple to make the changes to move to the Metro API. Now, after we got all these changes in, it's in a branch on our website. Then we had to test it. And if you know anything about SQLite in our culture, we're really into testing. We've got millions and millions of test cases. We test all of our code to 100% branch coverage testing. That's a 100% modified condition decision coverage, MCDC. And we ran all of this against Metro-style apps and Windows 8, and everything's working great. Windows 8 handles everything we've thrown at it so far. All this code is in a branch right now, but our plan is when at the next major preview release of Windows 8, which I'm told is going to occur in about 3 weeks.
3 weeks.
We're going to merge all these changes into the SQLite trunk, and it's going to be officially supported. You can download the code now. You just have to go to the branch and get it yourself. Within 3 weeks, the next release of SQLite is going to have this in there by default. SQLite comes as a single source file. Now, when we developers are editing it, we've got a few hundred source files. But we package it all together in one big source file called the amalgamation. Well, there's a header file that comes with that defines the interface. So if you want to use SQLite in your Metro-style app, you take these two files, the header file and the source file, you drop them into your project, you press F5, and then you've got an SQL database standalone built into your Metro-style app. Everything's working great. In summary, it took us very little time to port it. Go to the website, download it. We've got a mailing list online. We really want you to get on there, tell us what you're doing, and tell us how this is working out for you. Thanks a lot. Thanks, Herb.
Thanks, Richard. So we're looking forward very much in 3 weeks to having a production-supported version of SQLite also usable in a Metro application. Now, there's a couple of things I want you to notice in particular about this porting effort. The first was not all Windows existing APIs are allowed in Metro apps that you're going to put on the store. And that's for often security and confidence reasons, because we want to make sure that this is something that the people can download, know is going to not interact with any other part of their system, so you better not be writing to the C root drive, things like that. At the same time, making apps trustworthy, making them easy to wrap up in a manifest, to provision into the store, to download with one click and install and be safe and confident, required actually excluding very little. And so that's why if you're actually using many modern APIs and your application is just a few years old, very likely you will find that you might need to make very small source changes, if any, to be able to put them into the Windows Store. If you are using application and APIs that are a decade and a half old, the good news is those still work fine in desktop applications, and some of those will need to change. And that's where, in a project of that size, you can expect roughly a day or two of changes to be able to bring it forward. But we're talking about bringing either 99% or 99.9% of your code forward unchanged, and that's a great story for bringing things into the Metro environment and being able to build these fast and fluid apps without reinventing the world and without rebuilding from scratch. So once we've done that plumbing and we've used fast and portable code, how do we do the user interface? Because that's the eye candy that people really see and literally see and touch. How do you deal with not just wonderful world-class touch input, but also pen and ink and some of the other richness that's available on Metro apps on Windows 8. So let's talk about the options. If you're a C++ developer and you want to write a C++ app that presents a UI in Metro, you have three major options that you can use. The first two are options that are also available in C#. So the first is you can write an HTML5, nice, portable, modern HTML5 with JavaScript user interface, and seamlessly call from JavaScript into C++ because it's a natural WinRT boundary. And in fact, we can play some tricks to make that even more efficient than you might think possible. So a lot of work has gone there to make it not just seamless, but fast. Next, you could write a modern XAML interface using XAML and a markup language updated from XML to be able to define where your buttons go, exactly how you want your user interface to look in a nice, beautiful, scalable way, and still have most of your application written in C++. We've been doing this for years because we're used to building front ends in other languages over portable engines. This is exactly more of the same, using exactly the same models we've been using successfully for many years. But there's one more thing you might want to do. And this is not just for games, but for any rich, fast, high-performance UI. Very often you want to use something like DirectX that gives you fast, powerful, flexible, access to that graphics hardware and the pixels on that screen. In C++, using the Visual C++ compiler, you also have access to full DirectX, and you can use that in combination with things like XAML. And that gives you a lot of options to develop easily exactly what you want to present to the user. Companies like Autodesk have seen this. So Autodesk, if you take a look at the Sketchbook app in the store, they found that mixing native C++, the C++ we know and love, and C++ CX, which I claimed was for the boundary, was simple and a pleasure, and this is a key part. They found they did not need to migrate or convert anything in their C++ code. They added the wrap and it just worked. That's what we've been working really hard for the last couple of years to enable, and so we're really glad to see customers being able to do this. Another example is the Carmen Sandiego app. Now, how many of you have downloaded and are using the consumer preview? Okay, a good number of the audience, so over half. How many of you have played Carmen Sandiego, which has been on the App Store already for a couple of months? Okay, you have it. Have you enjoyed it? Yes. Okay, lots of nods. Beautiful game, ported very seamlessly and simply. Did you notice that it uses DirectX and XAML in the same application? Probably not. You just know you've got a stunningly gorgeous application and a game that's immersive that you interact with. But that game uses DirectX for its flexibility, its performance and speed, as well as XAML mechanisms that are new in WinRT, and it does it seamlessly. And I love how this developer, Christoph, pointed out that you can use them together without any constraints. Better together, but also no compromises. You can actually use these things together and they work beautifully. Another example, those of you who've looked at the Windows Store, I'm sure many of you saw the Pinball app and downloaded that. So Zen Studios developed that in DirectX directly. So here's a pure DirectX app for all of the richness and the lusciousness of a GUI and the responsiveness and the speed and frame rates. And notice that Victor showed that DirectX and WinRT were really easy to adapt to. And to get a game up and running and delivered is what we're all in the business of doing, is to get up and running, delivered, and in the customer's hands in as seamlessly a piece of effort as possible. That's exactly what's enabled with C++ and then provisioning in the App Store. When you think about some of the applications you see on the App Store, it's worth going into seeing exactly how some of them are built. And we are fortunate enough to internally have the Bing Maps team who delivered that beautiful Bing Maps application that you've probably used already, the Metro Style Maps application. So would we like to see exactly how that was built, what technologies it uses? Well, please join me in welcoming Steve Chang to tell us more. Steve?
Thanks, Herb. Hi, so I'm Steve Chang, and I'm a program manager on the Bing Maps app. So just to get a quick sense, how many of you have already played with the consumer preview version of the Bing Maps app? Okay, a little less than maybe a third. So when we started building the app using C++ and XAML, we were a little concerned about the typical things that you run into when you mix low-level graphics layers like DirectX with a high-level UI toolkit like XAML. And we had good reason to be concerned because we had actually built the Map app on other operating systems before, most notably iOS. And so we were fully expecting to run into issues of drawing order, clipping regions, the UI layer dragging behind the graphics layer, but we were pleasantly surprised to discover that none of those issues materialized, and it was very smooth and easy to develop the Bing Maps app in XAML, at least the graphics portions of it. So let me go ahead and show you the app. Now, a map application is just begging to be touched. And so performance is critical. So XAML and C++ was the direction that we felt we had to go. You can see that pinch zoom, it's super responsive. This is running at about 60 frames per second. And even when I bring up the application Chrome, so some of the XAML controls, it doesn't impact the performance at all. There is no performance degradation by doing that. If I start using the mouse, you'll see these zoom buttons show up. This is a great example of how the XAML compositor just takes care of a lot of the tricky things for us. There's no clipping, there's no ugly square box around it. It's all beautifully clipped to be the perfectly round shape. So that was a bonus as well. Let me go ahead and actually use the app. Let's say you guys are looking for I don't know, dinner options tonight. Let's find some sushi restaurants. Again, here we've got the XAML control that's super responsive up at the top. That does not impact the perf of the map at all. Moreover, when I tap into any one of these guys, you get the flyout, in this case for Mori Japanese restaurant. Again, the click events are going to XAML as well as DirectX without issue. No concerns there. Let's say I actually like Mori Japanese restaurant and I want to get directions to it. Tap go. And now you're actually getting a little bit more complicated. You're seeing the route line drawn, overlaid, so that XAML controls on top of the map. And again, no issues there. If you were to go with something a little bit more graphically intensive, let's switch over to aerial view. And zoom all the way in. Again, super performant, the route line's drawn correctly. Everything just works as expected. Let's clear the map, or actually I could even add traffic. And again, it's just beautifully performant and a delight to use.
Traffic's good this time of day. I wish it was always like that.
You and I both. So this is the consumer preview version. We're adding a lot of features to the Maps app, so please keep an eye out for it as release preview comes out in RTM and general availability. We're super excited to deliver this, and we've been very pleasantly surprised and just thrilled with how easy it was to actually get the graphics part of this app nailed.
Okay. Thank you very much, Steve.
Thank you.
Now, for the half of you who are running Windows 8 already and have not downloaded Bing Maps, it's a free install. Go grab it with one click, and you'll be able to find not just sushi tonight, but now that you know a bit more about how it was actually built, try it out with a developer's view in mind and saying, how could I do that? And that's what they did. And as we go through the day, you'll find more drill down on how you can build those applications yourself using DX and XAML together to build gorgeous user interfaces that are responsive and fast and compelling for customers. So we've talked about C++'s strengths as a portable language. We've talked about how it integrates well with all the modern tools for user interfaces, DirectX and XAML. Let's now talk about heavy lifting. Because when there's a demanding job to be done, that's what we're there for. That's our turf. So how does C++ work in the world of heavy computation, which these days is pretty much synonymous with parallelism? We still want to give you great optimization for straight line, single thread performance, and we do that and keep making that even better. But the name of the game today is parallel, because if you make that single thread infinitely fast, you're still wasting 1/8 or 1/64 of your tablet machine, because modern tablets have many cores, CPU cores, 2 and 4 is already common in off-the-shelf hardware. And they have SIMD lanes, vector units on each of those cores. So there you should be thinking about your modern tablet target as already having 16 or 32-way parallelism. Never mind the GPU that is likely also on board on top of that. Let's talk about how this works in Visual C++ 11. Most of what I'm going to show you on this slide is new in this release. And so if we look kind of tired, and the team members that you might have encountered look a little tired, it's because we've been really busy these last couple of years. Never mind WinRT. Never mind bringing up ARM as a target and lots of other good stuff. C++ 11 conformance, compiler work, standard library especially, but also parallelism. Speaking of the C++ 11 standard library, we're very proud to be able to ship in this release, as we've announced before, a complete implementation of the C++ 11 standard library, which I believe is the first major compiler to ship one that actually works on all the platforms, all the targets that the compiler supports. So we'd love to see the entire world marching towards C++ 11 conformance, and we've already announced that even more is coming later on, soon after our release, and we'll have more to share about that in the coming weeks and months. But what is already there today is the full C++ standard library, including the concurrency libraries, standard atomics, mutexes, condition variables, and especially async and futures. So I would love at this point to go off into an hour-long talk about why async and future are great and how you should use them. There's a course for that. But in a nutshell summary, async is the name of the game in modern applications because you must stay responsive. And what is in the standard already gets you exactly halfway there with high performance. So if you look at the code at the bottom of the screen, this is portable ISO C++ standard code. There's no Windowsisms here. There's no Visual C++ extensions. This is pure portable C++ code that soon all compilers will be able to compile. And all of this works in Visual C++ that you have today in the beta. What the std async function does is it takes any function pointer or executable thing, including a lambda. Lambdas are really convenient little beasts. And we just say, hey, I know what to call now. Just like in a synchronous function call, I could just call do something. But I don't need the result right now. So why should I do that as a synchronous call and block and wait for the result when I could be doing other useful stuff in the meantime? So by using async to launch the work, and we get back a future, so that auto resolves to a future of int or whatever the return type is of do something. That is a ticket redeemable for an int, which I can then put in my back pocket and walk over and do other work. And then finally, when I do need the result, pull it out and say, all right, now I might block if the result is not already available. But if it is already available, I just keep going without blocking. And even if it's not yet available, I am that much closer to my answer because I was able to do all this other work in the meantime. This is really useful and powerful. This is standards conforming and portable. On top of that, the implementation of async in the Visual C++ compiler is screamingly fast because it is built on the same runtime that powers the parallel patterns library, the concert concurrency runtime. This was possible because several people of the standards committee helped to make sure over the course of a couple of years that the default launch policy for std async was in this or another thread. Seems like a really small thing, but it's that default that makes it possible to run this efficiently on a work-stealing implementation, which if there's no other core ready to take the work because the whole system happens to be busy at this particular microsecond, or because I'm on a single core machine, grandma's PC from 10 years ago, I will just run it on this thread. Or if the work is too small to be worth shipping somewhere else, I'll just run it on this thread. And this is all done automatically. All you had to do was express the potential concurrency and parallelism in your application in a very simple way. Now, there are two things about this. This is great. It's absolutely great. And the Standards Committee is already moving to move this forward because there's two things that we would now like to also do. The first thing is we would like to have groups of these. So you don't just get this global async function that launches everything. I'd like to be able to say, here, launch these 15 things and then wait for those 5. And in a better way than just cobbling together the futures. I would like groups of tasks. And so we're looking at adding that into the standard. And the extensions that are in the parallel patterns library in Visual C++ are part of what's now being considered for contribution to the new C++ standard that's going to be coming up next, that we're working on now. In particular, in this release, one thing that we've added is in the task, which is our non-standard future. So we deliberately named it otherwise to not conflict with the standard one. But think of task of t just as future of t. But what we added as an extension on there in this release is .then. And if you've ever done JavaScript, you know exactly what that is. That says, when you get this result, do the following with it, but it is non-blocking. I know what to do with the result, but I'd simply queue it up and keep right on going, and there is no waiting, no deadlock, no performance degradation, no frozen UIs. This is 21st century code that we are going to write all the time. And so expect to see something like this, if not with this exact syntax, something probably very similar in a future version of standard C++. You can use it today. So in this case, you can say on this particular group of tasks, run this other new task, compute this value. Do other work to compute a second value concurrently. And now I know what to do once I've got both values. I've just computed one, and I've spun off the task to compute the other one. I want to combine them by calling use val1, val2, but I don't need to do it now on this thread. So I've got the second value. I capture it by value. I capture the future for val1, and I just go and tack that on as a continuation on the task that is already doing the work for me to compute val1. And this is completely non-blocking. It's nicely concurrent, and I can understand this code. I can write it easily and come back 6 months later and still understand what it means. It's maintainable, and it's robust. On top of that, people keep asking, wouldn't it be nice if the compiler could just parallelize my code for me? And while we're talking about rainbows and unicorns, yes, that would be nice. The good news is there may not be unicorns, but there are rainbows. So we can get part of it a lot of the time. Now, one of the cool new features that was written by the back-end team who control the code generation and optimization of the Visual C++ compiler, they did a lot of work to enable automatic parallelization and vectorization in this release. If you're using the beta compiler, you've already had it in your hands for some time now. And what that does is it says, I'll take a look at the basic loops in your program, and I will see if I can just determine that it's safe to parallelize that, because I can see enough of it. And this happens at two kinds of levels. So the code shown below is actual code that a few days ago we compiled and verified that it was in fact being both parallelized and vectorized. Now let me describe what that means. Parallelized, we use that term to mean runs on multiple cores. So if you've got an 8-core desktop, spread it across 8 cores. If you've got a quad-core or a dual-core notebook, spread it across those 2 or 4 cores. On top of that, every core in any modern processor also has a vector unit. And all that means is they're called lanes instead of cores, because it's basically an instruction at a time. If you look at the assembly, instead of seeing add, you might see padd for parallel add, which instead of taking a single location takes an array of 4 or 8 locations, and in a single cycle does 4. This works really well when things are nice and contiguous and control flow is predictable. In this particular case, for the inner loop, the compiler notices that, hey, we're doing operations on an array. And it may be a C array, it might be a std vector or a std array. And I can see I'm touching every element, and I can see exactly what's going on. I can optimize this to, you can think of it as partly unroll the loop, to do 4 at a time or 8 at a time in parallel and get that direct speed up. And that vectorization especially works great for inner loops. When the loops contain even a little bit more work to be done, such as this outer loop, which is, it's only doing instant floats and some array dereferences. But that's enough work in this case to let the compiler also say, you know what, I think I'll chunk up that loop and run it on multiple cores and just spread that work automatically across multiple cores. Now, caveat, we want to make sure you understand what you're getting here. Automatic parallelization, you get exactly 0 effort, you get potentially some reward. There is no guarantee that we will actually parallelize or vectorize a loop. It will happen a lot of the time, however. If you want to add hints, there are pragma hints that you can add to loops to encourage the compiler to, by the way, look here, and to control that. But even though this is not as deterministic as if you wrote, say, a parallel for each loop in PPL or in C++ AMP, like I'm about to show, this still gives you a lot of gravy and a lot of goodness, and you will find great speed-ups and performance in your code. Plus, it takes a lot less power. It takes a lot less power to run your loop 4 at a time in a vector unit instead of 1 at a time in the ALU. Something to keep in mind when we're trying to do computations. In this release, because all that other work wasn't enough, we also said, GPUs are already available on something like half the installed base of the world. And in fact, many tablets that you can go down to a store and buy today already have compute class GPUs sitting in them. So what C++ AMP does is it says, how would we build a C++ programming model for enabling you to do that with as little friction and as little difference from the C++ way, and leveraging all of C++'s power, its strong typing, its genericity, the ability to be able to predictably write generic algorithms, to work with STL iterators. And so what we've done is, in the same namespace as PPL parallel for each, there is an overload of parallel for each, which today is separate, but we are going to converge. That's our plan to converge in future releases. That instead of taking a container, it takes a set of indices and says, for each of these set of indices, go through and do this stuff, which you can then dereference into an array. And then you say restrict AMP, because the GPU cannot handle the full C++ language today. Typically, you can't throw exceptions over there. And so restrict AMP is the only language extension required. You say that, it makes sure that you program in this slight subset of C++ that the GPU can reliably understand for many models of GPU. Then we'll compile this and give you a binary that you can put on a user's machine, and if they've got an NVIDIA GPU, it will use it. If they've got an AMD GPU that's DX11 capable, it will use it. If you are running on a machine without a GPU, or with just like a small integrated GPU or something that's not compute class yet, because they're all going to be really soon, but if there's no GPU yet, even the C++ amp loop, we will be able to spread across cores and across lanes of vector units. And we're actually quite pleased about that because that was a stretch goal. And so it's already partly there in this release, and we hope to make that even higher performance in the future, but it already will spread that workload over the cores and vector lanes of your CPUs, even if you don't have a GPU. So when we first announced this, we mentioned, oh, it's only GPUs in the first release. So you might have noticed a couple of months ago we added, actually, by the way, now we can tell you, on Windows 8, we can leverage the new Warp technology, which allows us to spread this across CPUs and lanes if you're running Windows 8. This will work if your customer is running Windows 8. Now, why do we care? Let me just emphasize why we care. If you look at the latest hardware, it already has this juicy compute capacity that we want to exercise. The NVIDIA Tegra 3 part, which is brand new, which is powering a lot of new devices and tablets, notice it has those 4+1 CPU cores. A very nice +1 there for low power. If you want to use this part and get the most compute out of it, you need to write parallel code using those kinds of tools that we just gave you on the previous slide. And on the rest of that is cache, and of course, this is NVIDIA, GPU cores and lanes. You want to use those as well. And there, a C++ amp parallel for each is your friend to spread it across all of the compute capacity of that device, not just the CPU cores, and especially not just one CPU core. If you look at Intel's Ivy Bridge, great part. And again, it contains CPU cores as well as processor graphics, which are getting better and better. And as you have compute class processor graphics and cores, you want to make use of all of that because the GPU is not just for graphics anymore. 3 days ago, AMD announced the Trinity part. So this is breaking news. And if you look at the architecture, you will see the usual things. Guess what? It's got cache. It's got a memory controller, a memory bus. This is not really surprising. Of course, it also has dual-core x86 modules. So you got quad-core plus GPU. And if you want to get full performance out of this part, this happens to be a desktop part. But you can get similar mobile parts, and this will be desktop, like who knows, like next year. I'm not making a product announcement, but this is where these things always go. They'll trickle down. This is the kind of target we already need to look at, and that is clearly coming even more in the future to smaller and smaller and lighter factors. We want to use all of that because that will give us a competitive edge. It will give us an advantage in delivering to our users a fast and snappy and fluid experience. Now, when you look at all of these things, we've talked about the parallel patterns library, C++ AMP, std async. We've talked about taking existing code, like libraries that use Boost and STL, and all of your existing conforming portable code. We've talked about XAML and DirectX. We've talked about the Windows Store, the storage engine. And we've talked about how you can use this all together in a single application. You can use whichever parts or all of it in a single application with Visual C++ 11. To demonstrate that, let's see an app that we have created inside our own team in Visual C++. And to demonstrate that for us, I'd like to welcome up my friend and colleague and partner in crime, Vikas Bhatia. And please give him a welcome.
Thanks, Herb. So, am I on? Yeah. So we created an app in our team. We're calling it Journal. It's a very, very early prototype to show everything that we've added in Windows 8 and Dev 11 and kind of showcase all those technology areas. So I actually wrote this down before coming here, just to make sure I capture everything that we've used. Of course, we're using Win8, the touch and stylus support, XAML, DirectX, XAML and DirectX together, 3D, a fast and fluid UI, light manipulation and camera manipulation, WinRT, of course, Win32, PPL, STL, Boost, the SE database jet engine, C++ AMP, and the vectorizer. So these are just the technology areas. But you got to remember, when you're creating an app for your end users, all of these have to fit perfectly in a seamless way. And that's your job as app developers. So let's get started.
So you could use any or all, but here in this particular case, you found uses that really give an advantage to your application for each one of them. Yeah. So what's this that we're looking at here?
So this is a note-taking app, a general note-taking app that we've created. And as you can see, we've created some notes in our team. So we've been using this app within our team, and everybody goes and puts in some notes. And you can see that we're using some shadow mapping here with a light source. And I'm using my finger and using touch, so I can zoom out. And if I want to zoom out again, I can zoom out. And now you have a stacked view, and I can go back in.
So that's important in Windows 8. If you want to go to any talk, the Build conference, they're all online. My favorite of the whole conference was Jens's talk. Jens is his name, on how to build Metro-style apps. It talked about contextual zoom and all the UI metaphors that are really leading edge in the industry and how they work well together. So definitely go see that for more about that. But I love you're using contextual zoom there.
Absolutely. So let's go on. I'm going to zoom in on a particular page here. Let's take this one. And I'm showing the light source. And I can turn the page like such. And you can see there's a nice page curling effect with cones. And so we've taken some algorithms, a math algorithm, doing some sine, cosine, some point usage over here. And you can see I can turn the page very seamlessly here. And as I show here, we're using the SE storage right at the bottom. And I could turn a single page like such, but it might be faster to do this. Scroll right till the end. And the point to note is we actually have thumbnails that we've stored of every page. But we're doing background load. So when the page actually comes to the front, we're going to use the Jet SE database engine and along with PPL to load the content so that it's completely asynchronous and users don't feel a lag. And this is exactly what you were talking about with async and PPL.
You always want to stay responsive, launch work, but then don't wait for it to keep generating your UI.
Absolutely. So let's go here, and I'm going to add a new page. And you guys remember these, right? Styluses?
I love those. Because I love touch. There is nothing like modern touch. But when you want to write, you want a pencil, not a finger that acts like a crayon.
Absolutely.
Sorry, this is my personal opinion, not Microsoft policy. This is just my own personal opinion because I love OneNote and I love what you've done here.
Now, the other thing that you get with the stylus is the pressure sensitivity. So if you use a finger, you just get the outline of a finger. But with the stylus, I can actually do a thin line. This might be better if I showed you a different thickness. A thin line, a thick line, a thin line, a thick line. So I know that I'm using the pressure sensitivity of the stylus to get the feel. If I were doing my next Picasso painting on this particular app, I want this, right? So the other thing that you may have noticed, what is this menu on top? So DirectX is great for 3D stuff. It's great for GPUs, shaders, vertex shaders, all the good things that you can throw together to create a great DirectX app. But it's a little complex if you want to create simple XAML elements, such as the plus and minus that we saw in the Bing Maps ad. Or in this case, I want to show a menu that people can choose the different style of pen or change the color of their pen. So the menu that we see on top is XAML. And here we're using the XAML and DirectX integration together. Cool. And you'll hear a talk from Jesse later on. We're using the swap chain background element to do this kind of work. So let's add another page. Let's go back. And again, I'm using the Windows 8 contracts. I'm going to choose an image. Let's see, which image do I like? How about this guy? A great cappuccino.
I missed that this morning.
And you see I'm using the two-finger touch. I'm zooming in and out. Again, one of those Windows 8 design elements that you can use together. I'm going to go back and choose a thinner pen and say, Herb wants
okay.
this. All right, great. So the other thing to notice, let's do one more. Let's choose a thicker pen this time and do this. So the point of this, I'm going to show you. I'm going to zoom in a bit more. Oops, not so much. So you can see that the red ink, there's a little serration. But when I turn, the smoothing is on. If I turn off smoothing, you see more blurring happening, right? So with the help of the vectorizer, we are doing a lot more parallel instructions together to get that smoothing effect that users don't even notice. And that's one of the powers of C++, that you can do all of these things together to create this beautiful looking app for your customers.
So especially that smoothing is using the automatic and the parallel vectorization in the new compiler.
Absolutely, absolutely. So let's do some 3D. Let's zoom in, and I'm going to use my 2-finger and collapse my pages. Oops, maybe not. There you go. So to do 3D, I'm going to turn on.
Ooh, instrumentation. We love this.
Of course. We need instrumentation. So I'm going to show you the frames and do that and escape out, and pressing zoom, I'm going to zoom down, and I'm going to use the rotate function and rotate my view. There you go. And isn't it fun to rotate a page in 3D with my page curling algorithm? Look at that.
So when you were showing the effect, it wasn't just that you were simulating 3D because you happened to be looking down on it. You were really doing 3D, it's just your view happened to be face on before.
Absolutely. So as you can see, I'm actually doing 3D here, and I'm turning the page around. But see, it's even more fun when you see what actually happens in the background. Your pages are stacked one after the other. So the page collapses and expands, and we get a nice little 3D effect.
It wasn't just some fake 2.5D effect.
No, no. And Tim over here really likes this lentil soup, so I'll get you the recipe. And let's have some more fun. Let's zoom in a bit. There you go. Gratuitous animation is what I call this.
Just because you can.
Yes, just because we can. But isn't it kind of cool?
Now, by the way, you never actually said what kind of device you're running. I mean, I'm running my entire presentation off my production machine, which is a Samsung Slate 7 that I got about a month ago, running Windows 8 Consumer Preview. I bought it to try it out, and I realized it was stable enough to use as my production environment, and I love it. And I wrote my last 2,000-word article on the plane yesterday entirely on the keyboard. So I'm loving it, and said, well, that's what I use, so that's what I'm going to present from. Now, you're using actually slightly older. By the way, I just got this at the Microsoft Store. Anybody can buy these. They're available today. But you're using a slightly older device, or the same one? It's also a Samsung, isn't it?
It's also the Samsung. It's a slightly older device. These are the Samsung devices that we gave out at the Build conference.
So this is the performance you can get off last year's hardware.
So last year, it was only September, right? This is technology for you. But you know, we could just add one animation, but we thought, why stop at one? Let's do 2. How cool is that?
Makes it hard to read, but I love it.
It's awesome, right? Now, there is something called the normal calculation here, and we created, a performance monitor just for fun. So you can see the frame rates, you can see the normal calculation. We talked about AMP. Let me shut off AMP. AMP is actually on right now. Oh, it's actually off. So I'm going to turn it on. Notice that I'm getting, right at the bottom, I'm getting 7.2 seconds for normal calculation.
That's in the green, at the bottom of the green chart.
Correct. And once I turn it on, let's do this, I get 1.6 seconds for the normal calculation, which is used to calculate the shading when the page goes up and down.
So for off-the-shelf tablet hardware, you can use GPU acceleration just for compute. Now, we happen to show something graphical just because in a talk like this, you want something you can actually see. But remember, this is not about just graphics. You can use it for heavyweight financial calculations, derivatives trading if you really must, and any other kind of heavy-duty, heavy-lifting number crunching.
All right, great. So let me turn it off just to show you what it does. Up to 7 seconds. Turn it on.
And that green chart, you can see the latency going up and down as you disable and enable the GPU.
Yeah, but I don't have a DX11 card here.
Oh, that's right. I just was saying GPU, and that was actually my error. I did not mean to say that because this does not have a DX11 GPU installed. So how did you get this? Oh, that's right.
It's called Warp, right? With Windows 8, you get the Warp acceleration, which is now working for me. And in fact, just to do this demo, we had somebody convert our existing CPU code into this parallel for each algorithm, and they did it in like less than 30 minutes. And they were new to this technology.
That was convert to C++ AMP,
which
would use a GPU. I misspoke, were it available, but even though one isn't, it spreads it across the cores and the vector units on those cores.
Absolutely.
on mainstream tablet hardware.
Yep. So let's turn this off. Let's go to the main view. I could do, one more animation here just for fun. But let's see. Now I'm going to go back, minimize this, and that's our team. I had to give a shout out to our team.
Well, thank you, team, and thank you, Vikas. I appreciate it very much.
All right, thanks.
So we have done a lot of work in the last couple of years, and you can use all of these things together. Now, remember, most of what you saw works fine in a desktop application too. So if you're writing a desktop application today and you want to spread work across the lanes of a vector unit on your CPUs, or you want to use a GPU, that works on desktop too, fully supported. Pry1 use case, we want to make sure that always works and it works better than ever. It just also works for Metro-style apps, and that's why we're focusing on just that part today. It is not only Metro. What you're going to see over the rest of this day is talk about porting and existing code and getting the most out of the compiler using C++ directly itself. You're going to hear about UI stuff, XAML, DirectX, and using them together with deep dives into code as to how to do that. Network-connected applications, handling latencies from that and anything else to stay very responsive. Writing WinRT components, because we are a library building language, and that is not changed with WinRT. We are still great at building strong libraries. We can now just surface them with a WinRT interface so that lots of other code can use them directly. And we're going to have an introduction to the Windows Runtime library and a few more videos and talks as well. That gives you an overview. It's going to be a full day. And the last thing I'd just like to leave you with, we've talked about how C++ works well in a Metro environment and how it interacts through metadata. We talked about how C++ has strengths in the blue, that's familiar, fast, and portable. The user interface strengths, XAML, DirectX, HTML, JavaScript. Heavy computation and parallelism, pick your flavor, and they all work well together to express the maximum amount of work that you can do in parallel in your code. As we look at these things, one of the things that came to my mind is that it made me think a bit of a talk that Steve Jobs gave a few years ago. And we really miss Steve. It's a real loss to our industry. But he's so quotable. And as I was putting this together and as I was thinking about the last couple of years of the work that our team has done, because with tablet revolution going on, with GPU revolution going on, with a new architecture being brought up for ARM targeting, plus a few other things, guess who's at the center of the hurricane when everything in Microsoft is built on C++? So that was a lot of work for us, and we've been really busy. And as I look back, I realized we have done more work in this release than I can remember ever us doing in any single release of Visual C++. And we're very happy to be able to birth it and give it to the world and to make it available to people to use to write stunning and gorgeous applications. Because that's where you come in, and that's where you're going to do very well. But when I thought of these things, it did make me think of a talk that Steve had given. And so with apologies, and please indulge me for a moment, in indulging parodying, or at least borrowing from, a very great man. We have done so much work in this that it seemed to me that we have built 3 world-class products in this release cycle. We have been able to showcase to you one of the most conforming C++ compilers in the world, with more conformance to come very soon after RTM for the standard and the full standard library now already, with portable code and a modern compiler. We've also been able to showcase a great interface, the Metro-style compiler that delivers beautiful and stunning apps in a fast and high-performance and battery-friendly way. And we have been able to ship a native language compiler that's great for heavy lifting and parallelism. Familiar and portable. A compiler that does great UI, Metro XAML apps. One that does great heavy lifting and performance parallelism. And of course, they're just one compiler. And we call it Visual C++, and we are so glad that you're here today to learn more about it. And we think that by the end of the day, your brains will be full, but hopefully you'll be full of ideas as to how you can leverage these great tools to build world-class applications that we'll be reading about, and we look forward to that. So thank you for coming. Enjoy the rest of the day, and we hope that you enjoy building Metro apps on Windows 8 in C++.